These are binocular cores, also known as multi-aperture cores or pig nose cores, all because of the appearance. This is meant for the output transformer or T2 in VU to EVQ linear amplifier, RF linear amplifier circuit. The smaller one is meant for input or T1 transformer in the same radio. So these are binocular cores. These two are standard toroids with a single core each. In VU to EVQ linear amplifier, these are used for RF chokes. In radio frequency design, while standard single toroids are common, binocular toroids are often the preferred choice for broadband transformers and balance. The primary reason is that binocular cores provide a shorter magnetic path and superior magnetic coupling for a very small number of turns, which is critical for high frequency performance. Here are a few key advantages of binocular cores. Two holes allow the wire to be completely surrounded by ferrite material. This results in much tighter coupling between primary and secondary windings compared to a single toroid. Because the wire spent outside the core is minimized, there is significantly lower leakage inductance. This extends the upper frequency limit of the transformer. Binocular cores have a very high inductance per turn factor. You can achieve the required magnetizing inductance with just 1 or 2 turns, which keeps parasitic capacitance low. They are industry standard for wideband applications like HF, VHF amplifiers because they maintain a flat impedance response over a much wider range than standard toroids. In RF circuits, every millimeter of wire acts as an inductor. When using a standard toroid, you often need multiple turns to get enough inductance. These extra turns create stray capacitance between the wires, which causes the signal to degrade at high frequencies. With a binocular core, you can achieve the same electrical result with a single loop through the holes. Because the copper is almost entirely enclosed within the ferrite, the energy is transferred through the magnetic field of the core rather than through the air, making it much more efficient for broadband signals. Binocular cores are used to combine signals from two transistors while matching the impedance to 50 ohms, as you can see in the circuit diagram of VU to EVQ linear amplifier. Converting a balanced signal like from a dipole antenna to an unbalanced signal like a coaxial cable is done by a balun, for which you can use binocular cores also. Broadband matching is another purpose. So it is useful in amateur radio equipment where the device must operate from 1.8 MHz to 30 MHz or higher without tuning.